Students, welcome to s.mathguru classes. So today start some remaining problems about partial derivatives. In partial derivatives, we consider this problem: if x to the power x, y to the power y, z to the power z equal to c, show that at x equal to y equal to z, del square z del x del y equal to minus x log ex whole to the power x into log ex whole to the power minus 1. So this is you have to show. Now we start this problem. Solution is start. Given x to the power x, y to the power y, z to the power z equal to c. So this is functions for function. So taking log on both sides. If we taking log on both sides, then we get this one log c. Again in logarithm function, if we get into, we know this formula log m into n, this is log m plus log n. We know this formula. So here log x to the power x plus log y to the power y plus log z to the power z equal to log c. We get this. Again you know logarithm formula log m to the power n log m. This power becomes in front side and we get this. So this will be x log x plus y log y plus z log z equal to log c. This one you can get. X log x plus y log y, z log z equal to log c. Now we differentiate partially with respect to x and taking z as a function of xy. So if we taking partially differentiate partially with respect to x, then we get, and taking z as a function of xy, then we get this is y log y plus del x z log z, this is del x log c. We get this, and this is product of two function. First function del x of second plus second function del x of x, and this is constant, we get 0, but we assume z is a function of xy. So this is product rule using z del x log z plus log z del x z, and this is log c is constant, this one 0. Now this will be x, ddx of log x means 1 by x, this is log x into 1 del x 1, this is z using chain rule, this is log z del z into del z del x. So using chain rule we get this, and this will be log z del x equal to 0, because you know ddx of log x is 1 by x, but this is z, this one x, these are different. So using chain rule z same, and this is 1 plus log x, this is z 1 by z del x plus log z del x equal to 0, and this one 1 plus log x, and from these two log x common, this cancel, del z del x common, 1 plus log z del x, we get this equal to 0, and this will be 1 plus log z del z del x equal to minus 1 plus log x, and this implies we get del z del x is equal to minus 1 plus log x by 1 plus log z. This one, this is number 1 we consider. We get this one. Next we differentiate this one. Again differentiate this one, number 1 this one, and this is number 2 we consider 2. We differentiate this with respect to y, and same z is a function of xy. We consider this. Again we get del y. We differentiate this equation number 1 with respect to y partially. Del y x log x del y y log y plus del y z log z del y log c. So we differentiate one partially with respect to y, and with respect to y means this is 0, and this is product rule. First function del y log y plus log y del y y, and this one product of two function z del y log z plus log z del y z, and right hand side 0 because log c is constant, and this will be y, this is 1 by y log y, this one 1, and this is z using chain rule, log z del z del y plus log z del y equal to 0, and this implies 1 plus log y z 1 by z del y, and this is log z del y equal to 0. So this is 1 plus log y, this is 1, and taking del y common, and this is z cancel, we get 1, and this is log z del y equal to 0. This implies del y equal to minus this one right hand side and dividing by this. This is 1 plus log y by 1 plus log z. We get this one del z del y equal to, we get this. But in our answer del z del y we differentiate with respect to x. This one we differentiate with respect to x, we get. So we differentiate this one partially with respect to x, because here del square z del x del y given. So this one we differentiate partially with respect to x. Now del x del z del y, this equal to minus del x 1 plus log y by 1 plus log z. This one I get. Just we differentiate both sides partially with respect to x. We get this. and this implies del square z del x del y minus remains same, and this is division formula, quotient rule, 1 plus log z whole square 1 plus log z del x of 1 plus log y minus 1 plus log y del x 1 plus log z. We get this one, and this will be 1 plus log z whole square 1 plus log z. We differentiate with respect to x, y is constant, so this is 0, minus 1 plus log y, and if we differentiate this is 0, and log z 1 by z del z del x. We get this one. This term is 0, this minus we get plus we get 1 plus log y and 1 by z in front side del z del x divided by 1 plus log z whole square. This term is 0 and minus plus, this minus plus we get plus 1 by z log 1 plus log y del z del x, we get this. So this will be 1 plus log y by z into 1 plus log z whole square into del z del x. Del z del x we know from this. This value is minus 1 plus log x by 1 plus log z. We get this. So using result 2, by using 2 we get this one, del z del x. From this we putting this value, and this minus becomes in front side, and this will be 1 plus log y 1 plus log x and 1 plus log x log z 1 plus log z, the whole square, and this we get z into 1 plus log z whole cube, this into this whole cube. This is del square z del x del y. We get this one. Now after calculation we get del square z del x del y equal to this, but our given condition, given x equal to y equal to z, these three values are equal. Since x equal to y equal to z, this is our given condition, so we putting z y both are x. So therefore del square z del x del y minus 1 plus log x 1 plus log x by 1 plus log x whole cube, because z equal to putting x, y equal to putting x, because x, y, z are equal. So this 2 will be cancelled. We get minus 1 by one thing is that this z is here, z also putting x, this x 1 plus log x we get this one, and this is 1 by x, 1 means log e means 1, this, and this is log of x. Again in logarithm, if it is addition given, then we can write multiplication. So this will be 1 by x log ex, just this into this. Again using logarithm formula you get log e plus log x, and this can be written as because we know this formula log E means 1, and also we know log mn equal to log m plus log n. If addition given, we write multiplication. These are addition given, we write multiplication. But our answer given this. So what we get? Therefore we get del square z del x del y minus this one, if we taking numerator, log ex whole to the power minus 1. This is the complete proof. Solution is long, but this is not difficult. By solve systematically, answer will come. These are proof short. This are very nice. Another problem. If z equal to y into f of x square minus y square, show that y del z del x plus x del z del y equal to x z by y. We have to show this. Now solution is start. This is very nice solution, very easy solution. Since z equal to given y f of x square minus y square. This is number 1 you consider. In our solution, del z del x given, del z del y given. So we differentiate partially with respect to z x first. On both sides, we differentiate partially with respect to x. So this will be y f of x square minus y square. And we differentiate partially with respect to x means y is constant. So we get del x f of x square minus y square. We get this one. But we know this ddx of fx equal to f dash x. When we get this result, if x same, then we get this result. And here these two are not same, so we find this will be same by using chain rule. Del x square minus y square into del x square minus y square del x, this, and this is y f dash x square minus y square, this is twice x, this is 0, then we get 2xy f dash x square minus y square, this is del z del x, we get this one. Next we differentiate with respect to y, this one, again del z del y del y y into f of x square minus y square, this. So here with respect to y means y is function, this is also function, using product rule, y del y f of x square minus y square plus f of x square minus y square del y, this is y, this one. Now here also is using chain rule, because if x same, then we get f dash x, but here these two are not same. So using chain rule we get del f of x square minus y square del x square minus y square into del x square minus y square del y plus f of x square minus y square, this is 1. We get this, and this will be del z del y y f dash x square minus y square, and we differentiate with respect to y means x constant, this is 0, y square means twice y, plus f of x square minus y square, and this implies minus 2y square f dash x square minus y square f of x square minus y square. This is del z del y. So taking left hand side, in our left hand side we get, taking left hand side we get y del z del x plus x del z del y, and putting the values y del z del x del x we get just this value 2x 2xy f dash x square minus y square. This is the value of del z del x. Next x del z del y, this is the value of del z del y, minus 2y square f dash x square minus y square plus f of x square minus y square, and this will be 2x y square f dash x square minus y square 2x y square f dash x square minus y square x f of x square minus y square. These two are like terms in opposite sign. This will be cancelled. Answer you get x f of x square minus y square. Therefore, what we get x del z del x plus y del z del y x f of x square minus y square. We get this. But in our result f is absent. F absent. So f absent means anyhow do or die, anyhow we remove f, because our result x is f is absent. So in 1 implies we get z equal to y f of x square minus y square. This is our 1, and this implies f of x square minus y square equal to z by y. We get this, and putting the value of f x z by y, putting this value we get our final result. Therefore x del z del x y del z del y equal to xz by y. Yahoo! So this is our answer we get. X del z del x, y del z del y, xz by y. So this is our proof short. So dear students, these are nothing, very easy, just practice. Answer depends upon practice, how much practice you solve some problems. Answer 100% sure will come answer, but practice, it depends upon practice. If practice is increased, then your solution will be easy. Practice is decreased, then solution is very dangerous. Simple problem may be danger problem. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.